This is our video for 10.5. It's our first of two videos, and I tried to break it down as best as I could. And it's just talking about different angles that we can still create within circles. So the first one is talking about a tangent and a chord, and it is very similar to our inscribed and intercepted arc rule that we talked about. So it says if a tangent and a chord intersect at a point on a circle, so point A, then the measure of each angle formed is 1/2 the measure of the intercepted arc. So for example, if I want to know the measure of angle 1, I know it's half the measure of the arc that this angle is intercepting, which is arc AB. So that's exactly what we talked about with our intercepted arc and inscribed angle measures in one of the videos for 10.4. So if I'm looking at example A, I want to know what the measure of angle 1 is. Well, I know the measure of angle 1 is created by a chord and a tangent that intersect at the same point, which is point B. Therefore, angle 1 has to be the measure of AB, or half the measure of AB. So we'd be dividing 150 in half and see that that angle measure is going to be 75 degrees. In part B, it's just the reverse. I still see that a chord and a tangent are intersecting at the common point P, but now I'm giving you the angle measure. So to go from, instead of cutting the arc length in half and getting the angle measure, when you're given the angle measure, you're going to double it to get the arc length. So that means this red arc length is going to be 130 times 2, which is equal to 260 degrees. C is very similar to part A. I want to know the measure of angle 1, so that means I cut the intercepted arc in half. So we're dividing 172 divided by 2, and we're going to get 86 degrees. And for part D, it's a little bit more work. If I only have 128 degrees on the circle, angle 1 is not going to be intercepting that arc. Angle 1 is intercepting the remainder of the circle. So the first thing you have to do is 360 minus 128, because you don't have the measure of the arc that angle 1 is currently intercepting. So once you do that, you should end up with 360 minus 128, 230, hold on, doing the math in my head, 232. So that means angle 1 is intercepting this arc of 232 degrees. So then you just want to be dividing 232 by 2, and that will give you the measure of angle 1, which will give you 116 degrees. Okay. The next rules that we're going to be talking about, these are very important for you to understand because there's two different ways to solve the different inscribed intersecting angles and such, so do not confuse them. The first one is if two chords intersect inside the circle, so that would be B, D, and AC are intersecting inside the circle, then the measure of each of the angles is 1/2 of the sum of the arcs intercepted by the angle and its vertical angle. So I only wrote down the math for 1. 2, I can verbally say what that is if you want to fill that in as well. So angle 1 is intercepting arc DC, so that's the first measure that we're going to include, plus whatever its vertical angle would be intercepting. So we would cross over, and we see that the vertical angle would be crossing AB. So you add up those two angles and cut them in half, and that will give you the value of angle 1. If I was talking about finding the measure of angle 2, I'd be having 1/2 times BC plus AD. So you're adding up the two angles that are vertical and cutting them in half. If I was talking about a different type of angle that's intersecting at different parts of the circle, so this is saying if a tangent and a secant, so remember tangent intersects the circle at one point, the secant runs through the circle. The two tangents or two secants intersect outside the circle. So their intersection point is somewhere out here that would create the vertex of the angle. Then the measure of the angle formed is 1/2 of the difference of the two intercepted arcs. So notice angle 1 is intercepting arc AC, and it's also intercepting arc BC. So you want to take the difference of BC and AC. And remember, difference means subtraction. Always put the bigger arc first because we don't want negative values. These other two are the exact same math as the example here. It's just showing you how the angles can be drawn a little bit differently when the angle is outside the circle. So once again, when the angle is outside the circle, you want the difference of the two arcs that it would be intercepting, and you cut that arc in half as well. So we'd be taking 1/2 of PQR minus arc PR, and that will give us the measure of angle 2. And the last type of example, so see how these examples are all looking a little different, is to find the measure of angle 3, is we are saying 1/2 times the arc XY minus WZ. So to put that math into practice, let's start with number or letter A, and that is going to be using this first rule up here. So I want to know what is the measure of X. And I know that X said we have to add up the angles that the arc that it intercepts. So first 1/2, sorry, 1/2 times the angle that it intercepts, or the arc that it intercepts. So it intercepts QR, which is 174, plus the arc that its vertical angle intercepts. So the vertical angle would be directly across from X, and it is intercepting arc PS. So we're also adding 106. And you're just going to do the math. So I suggest adding up what's in the parentheses first. So I would be saying 174 plus 106, and you should have 1/2, and we're going to end up with 280. Yeah, 280. And then you're just going to cut that in half. So that means the measure of angle X is 140 degrees. Again, you always have to cut it in half. The first angle you write down is the arc it actually intercepts, plus the other angle its vertical angle intercepts. Same concept in part B. Angle 1 is going to be equal to 1/2 times the first arc that it actually intercepts, which is 131, plus the vertical angle, what that intercepts, which is 33 degrees. So if we just add up what's in parentheses first, we have 131 plus 33, and we're at 164. And when we cut that in half, we should be at 82 degrees for the value of angle 1. Now the remaining questions are all focused on the difference questions. So in part C, I think that's an easier one to start with. We are looking at angle X. Oh, that one's actually not my best one to start with. Let's look at F. Sorry, I'm going a little bit out of order, but I did not put it in the easiest order. So I know that angle 1 is found by taking 1/2 times the difference of the two arcs it intercepts. So 92 minus 43, because notice it intercepts both of those arcs. So again, the first math I suggest is doing what's in parentheses. So we have 92 minus 43 is equal to 49, and we're going to have a decimal. That's okay. What are we going to have here? That's going to be about 24.5 degrees. Let's do another one that's not as difficult. I guess they all kind of vary in their own way, so we can go back up to C. So I know that angle H is 72 degrees, and I know that is equal to 1/2 of whatever the two angles are that they intercept. So for my suggestion, when they give you the outside angle, and you know that it's half of the two arcs that it intercepts, plug in everything that you know. So I know that we're going to be taking 200 minus X, and that would have been equal to the 72 degrees. And then I would distribute, so I still have 72 is equal to 100 minus 1/2 X. What I would then do is subtract 100 from 72, and we're at 28 is equal to, negative 28 is equal to negative 1/2 X. And then to get X by itself, you'd multiply by 2 on both sides, or negative 2, so we're canceling out the negatives, and we're going to be at 56 degrees for angle X. So again, just plug in what you know and work backwards from there. Similar idea, let's move E down so I have room to show you. For E, I see that I have 80 degrees on part of the circle, and the remainder of the circle is left open. So this one's pretty straightforward for us to do. If I know that this entire circle is 360, I can say 360 minus 80, and that's going to equal 280 degrees. So therefore, to find the measure of angle X, I would be able to say 1/2 of 280, oops, not 380, 280 minus the other 80 that it intercepts, is equal to the value of x. So we're going to have 1/2 times 200, and that's going to equal 100 degrees for the value of x. So just use your rules of what you know circles are, so how many degrees there are and such. For this example, we're again going to have to apply a similar concept to what we just did for part E. We know that we have 170 degrees on the circle, and we also have 135 degrees on the circle. So we'd be taking away from 360, 135, and 170, because that will allow us to see the other arc that angle 1 is intercepting from this outer angle here. So it intercepts arc 170, and it's going to intercept whatever's left over from this math that we're about to solve. So if we do this math, we should end up with, let me think real quick, 55 degrees left over. So therefore, angle 1 is going to equal to 1/2 of 170 minus 55. And then again, to do the math on the parentheses, we're going to have 170 minus 55 is equal to 115. And again, an odd number, that's okay. We're going to have 57.5 degrees for angle 1. And I believe G is a similar idea. Yes, G is similar. So we have 95 degrees plus another 85 degrees plus another 175 degrees on the circle. I see that one of the arcs, angle 1 intersects is 85. So I now need to find the other smaller arc that it does intercept. So the first work that I would do, I don't know why it's going down to the next page. Super irritating. We're just going to move it down then for now. We're going to have 3. All right, I guess I'll write it above the question. We're going to have 360 minus 95 minus 85 minus 175. And again, the reason I'm doing that is I want to find this other remaining arc that angle 1 does intercept. So when we subtract all of those things away from 360, I'm left with 5. Therefore, angle 1 is going to be equal to 1/2 of 85 minus 5, because those are the two arcs it intercepts. And then we're going to have 1/2 times 80, and that will give us 40 degrees for angle 1.